and welcome back to Algebra 1. Our goal for today is to start to look at the process of simplifying variable expressions, which is very different from our process we've been doing, which is evaluating variable expressions. So you need to keep the two things separate. So when we started back with this screen and talking about the two different types of math problems that don't have equal signs, don't have inequality signs, called expressions, we said when we're over here for numerical, right? When I see numbers and stuff to do with those numbers, it always means do PEMDAS. No matter what the directions say, it might say evaluate, it might say simplify, it might say find the value of. There might be no directions at all and just a problem, and you know if it's just numbers and stuff to do with those numbers, you follow, please excuse my dear Aunt Sally, PEMDAS until you get down to one big final evaluated number. Over here with variable expressions, so far we've done that same process of evaluating, which is I'm told values to substitute in for the letters. Once I take out the letters and I put in the numbers, I no longer have an algebraic expression. I'm back over here in the category of numerical, which always tells me do PEMDAS or do order of operations. So everything we've done so far with our expressions led us down the path of doing order of operations. Today our approach is going to be very different because we're going to be over here with our variable expressions, but we're not going to be told values to substitute into our problem, which means we can't evaluate. All we can do is write the problem in its most basic simplified version. So the goal for today is if I don't have stuff to substitute in, how can I take a variable expression and condense it as far as possible so it's in its most basic, simplified, reduced version? So simplifying variable expressions for today. Take a second, hit pause if you need to, fill in your blanks. All right, our steps for today are pretty simple. We want to get rid of the parentheses, and the only way to get rid of our parentheses in these problems will be to expand using our distributive property. And the reason is inside of our groupings, there's going to be variables involved, so we can't combine. We'll have things inside there that aren't like terms, so we won't be able to combine them with one another. So to get rid of our grouping symbols, we're going to have to take that outside item and share it with our stuff on the inside. Now, this is way different than when we're evaluating using order of operations. Nowhere in PEMDAS does it say that we have to distribute, right? So we have to keep these are very different paths we're taking when we're either evaluating or simplifying with our variable expressions. All right, once there's no grouping symbols in the problem, to write the most basic, simplified, reduced version of the problem, we put all the things that would go in the same category of like terms together, right? We add them up or subtract them depending on what's in the problem. Be extra careful with your signs on your numbers here because it's going to totally change the values of your simplified terms if you change something that should have an add to a subtract or something that should have a subtract sign in front of it to an add. So be very careful when you do your distribute with your signs. So example number 1. We want to take this variable expression and write it in its most basic, simplified, reduced version. Right? We're not told stuff to put in for y, so we can't evaluate it to one number. All we can do is take our things that are like terms and put them together and write it more basic, more simplified. So the very first thing we're looking for are grouping symbols. If there are grouping symbols in the problem, we have to take the outside value and expand using our distributive property by sharing it to the stuff on the inside. This particular problem doesn't have grouping symbols, so there's no need to distribute here, and we can go to start to look for our groups of like terms. All right, in this case, we have things that have y's to the first. All right, I'll add it in here. Y by itself is a y to the first, and back here, a y by itself is a y to the first. Remember, the rule is they have to have the same letter to the same power to be able to combine them, so be careful. We have things that have y squareds that can go together, and we have things that are constant terms, which are just numbers that are going to be able to go together. All right, our next step is still a math problem. We're not just listing stuff. We're taking the original problem and we're adding stuff up. It's still a math problem, so be careful. We're just writing it in a more basic, simplified version. All right, I'm going to start with this y squared. It has nothing here in front of it, so please remember that's 1y squared. So we're taking this 1y squared and we're adding to it, right? A plus here, this 3y squared. So we're taking those two things and we can put them together. That's how we could simplify our y squared. So 1 plus 3 more would give us a total of 4y squared. Now the common mistake would be to say that's not y to the 4th. You're adding up how many y squareds. It's like you had them all laying on the table. You're like 1 here, another one here, right? And you're just counting them up. There's 4 of them total, and they are still y squareds. All right, might be helpful to eliminate, right? We've eliminated this plus 1y squared and this plus 3y squared. All right, let's go to our y's to the first. There's no sign here, so that's a positive or plus 16y to the first. So 16y to the first, and then minus an 8y to the first. So those can go together. So we have a 16 minus 8 to get how many y's to the first. In this case, we would have 8y, or 8y to the first power would be our exponent. All right, those are done. Let's go to our constant terms. We have a minus 3 plus 5 more. So negative 3 plus 5 would give us a plus 2. All right, no more like terms to combine. We're in our most basic, simplified, reduced version. There is nothing else we can do here unless we're told take y's out and put something in. There's just nothing else we can do at this point. All right, number 2, we want to write our problem, our variable expression, in its most basic, simplified, reduced version. All right, the first thing we're looking for are grouping symbols. If there are grouping symbols, we can't go and add up our like terms until they're gone. The way to get rid of them is take the outside thing and expand using our distributive property. So there's no number right here, but technically it's a 1. I'm going to add that in, and in this case, it's technically this negative 1. It's the thing that's going to get shared to everything on the inside. I'm going to bring everything else down unchanged. So negative 3m minus 4. We're going to distribute or expand using our distributive property with this negative 1. So negative 1 times this negative 6n. A negative times a negative will give us a positive, which will look like plus down here. In this case, 6n. So plus 6n. All right, negative 1 times our negative 5m here. Again, a negative times a negative is going to be a positive, which will look like a plus down here. Negative 1 times negative 5m would give us a positive 5m. And then we still have this plus 7. All right, we've already simplified a little bit, right? We've taken out the grouping, but we're not simplified completely. We want to write it in its most basic simplified reduced version. So we can still keep going by adding up like terms. We have things with m, things with n, and things that are constant terms here. So we're going to have 3 separate terms when we're done simplifying. M's, n's, numbers. All right, so let's start with our m's. Negative 3m plus 5m. So negative 3 plus 5 will give us a positive 2m. Done. Done. All right, let's go. Plus 6 has no like term, so it can't be simplified any further than just plus 6n. And then we have minus 4 plus 7, right? Those are constant terms. They're just numbers that can go together. So negative 4 plus 7 would give us a plus 3. So our most reduced version, we can't go any further than this. We have no more like terms, would be 2m plus 6n plus 3. All right, number 3, we want to write our variable expression. Negative 9n squared plus 5n minus 2 minus 6n plus 4n squared minus 7 in its most basic reduced simplified version. Again, we see grouping symbols here. Inside of here, we can't do 5n minus 2. They're not like terms. Do not try to put those together. Do not say that they're 3m because they are not. They are not like terms, so we can't take the 2 and add or subtract them. So the only way to get rid of our grouping symbols here would be to expand using our distributive property. All right, again, no number out here. So in this case, it's this positive 1 that's hidden there. That's the thing we have to distribute to the 2 items on the inside. So we have a negative 9n squared here. Positive 1 times 5n would still be positive 5n. And positive 1 times this negative 2 would still be a minus 2 or negative 2. Bring down minus 6n plus 4n squared and minus 7. All right, we've started the simplifying process. Right, that step is a little bit more simplified than the original because there's no more grouping symbols, but it's not the most simplified, most reduced version of the problem yet. So we have to keep going by combining like terms. All right, I'm going to start with my n's to the second. Remember, they can only go with other n squareds. So negative 9n squared and this plus 4n squared are like terms that can go together. When we add them up, we get negative 5n to the second. All right, those are done. Let's go to our n's to the first. We have a plus 5n and then this minus 6n. So 5 minus 6n would give us a negative n or negative 1n. So the most basic way to write it would just be minus n. Now, It wouldn't be wrong if I did that. Minus 1n means the same thing. And it really wouldn't be wrong if I put plus negative 1n. Those are all the same thing. But the most basic, most simplified, most reduced version would just be a subtract with the letter n behind it. All right, these guys are done. Our minus 2, minus 7. So negative 2 minus 7 will give us a minus 9. All right, negative 5n squared minus n, and then minus 9 would be our most basic, simplified, reduced version of our problem. All right, last two. All right, we want to write our problem 3 times 5h plus 4y minus 8 plus 12h minus 3 plus 5y, and its most basic, simplified, reduced version. Right now, we would say I can't combine like terms because I have grouping symbols in the problem, and inside of here, I can't combine those because they're not like terms. So the only way to get rid of the parentheses is to expand using the distributive property. So we're going to take this outside thing of 3 times. It has to get shared to all 3 of these items on the inside to remove the grouping symbols. So 3 times 5h would give us a 15h. 3 times 4y would give us a plus 12y. And then 3 times negative 8. Be careful, this is a minus 8 here. So positive times negative will give us a negative, in this case of negative 24, or minus 24. I bring down plus 12h, minus 3, plus 5y. All right, from here, we've already started the simplifying process. The red version is a little bit more simplified than that original. It's just not the most simplified, most reduced version yet, so we have to keep going by combining like terms. We have h's that can go together, we have y's that can go together, and then we have constant terms that go together. Please do not put your h's with your y's. They are not like terms. They are different variables. So let's start here. 15h plus 12h would give us a new total of 27h to the first. Not h squared. We're adding up. How many h do we have? We have 27 of them. All right, let's go to our y's to the first. We have plus 12 here and a plus 5 here. So 12 plus 5 more would give us plus 17y. Again, y to the first, not y squared. We're counting up. How many y's do we have? We have 17 of them. All right, minus or negative 24 here, minus 3 here. So negative 24 minus another 3 would give us a negative 27. All right, we have no more remaining like terms, so we are in our most basic, simplified, reduced version of the problem. Good final. Box it on in. All right, last one. We want to write the expression 3x minus the quantity 4 plus 6y plus 3x plus 5y plus 12 in its most basic, simplified, reduced version. Again, there are grouping symbols in this problem, and inside those grouping symbols, we have things that are not like terms, so we can't just put them together. So the only way to start simplifying here would be to expand using the distributive property. No outside number here. Again, this is a 1, and in this case, technically a negative 1 that has to get shared to everything on the inside. So boom, boom, boom. In this case, it has to get distributed to 3 other terms. So be careful. So 3x, negative 1 times 4 would be a minus 4. Negative 1 times 6y would be a minus 6y. And a negative 1 times 3x would give us a minus 3x. All right, we still have this plus 5y, and we still have this plus 12. All right, we've started the simplifying process. The red version is definitely more simplified than the black version. However, we still have things that are like terms, so we're not in the most simplified, most reduced version yet, so we have to keep going. All right, let's keep going here. 3x minus 3x is 0x. No x. So I'm going to say those just eliminate each other. Could I put 0x down here? Yes. 0 times anything, though, is just 0 or nothing. So the better version would be, I'm just not going to write that version. Right? I'm going to say this x part just canceled or eliminated and is no longer part of our simplified version. That would be the best way to write this problem. It wouldn't be wrong to have 0x, but I could write it a little bit more basic or simplified without it. All right, let's go to our y's. Minus 6y. Plus 5y. A negative 6 plus 5 would give us a minus y. I could write it like that, just minus y. That is the most basic, most simplified, most reduced way to write it. Now, I could technically do that because that's what's there. It's just easier or more basic to just put the negative y or the minus y. All All right, done with our y's. Let's go to our constant terms. We have a -4 plus 12. A -4 plus 12 would just give us a plus 8. Good final. Most simplified. No more like terms. We are completely stuck unless we're told take y out and put something in at this point. All right, I hope that helps you attack your work for today. See you guys later.